Hello, and welcome to the Quantum Slumber. Tonight, I want to take you somewhere you've already been, without realizing it, because you've heard the phrase light year 1,000 times, on documentaries, in movies, in casual conversation. It rolls off the tongue like it's simple, but if you ever stop and let it land, it becomes quietly overwhelming. A light year isn't a poetic way to say very far. It isn't a time travel phrase. It isn't a synonym for space stuff. A light year is a distance, a real distance, measured in the most honest ruler the universe gives us, light itself. And once you truly feel what that means, the night sky changes, not in a loud way, in a slow way. Because suddenly, the stars are no longer just up there. They become messages, old ones. Some are minutes old, some are years old, some are centuries old, and every point of light becomes a kind of timestamp, quietly telling you, this is how long it took reality to reach you. That's the strange comfort of it too. Even when space feels unimaginably empty, it's still connected, not by roads, not by wires, but by a steady river of light, crossing the dark without ever getting tired. So, tonight we're gonna make this idea feel real. Not with complicated math, not with a lecture, just by taking one calm step at a time until your intuition catches up, until light years stops sounding like a word and starts feeling like a place. And if you enjoy these gentle science journeys, if they help you unwind or shift your perspective in a quiet way, then you're warmly invited to like the video and subscribe for more episodes like this. It really does help the channel find the people who need it most. And if you'd like, leave a comment as well. Where are you listening from tonight? A city? A small town? A room with rain at the window? I love reading them. Now, take a slow breath. Let your shoulders soften. And let's begin with something human. Something close. Before we drift gently into the distance. Most of the distances you deal with in a normal day aren't really numbers. They're feelings. You don't think, I'm going 2 miles. You think, that's a quick run, or that's a bit of a drive, or I should probably leave early. Distance, at a human scale, is stitched to experience. It's tied to the way your body moves through the world, the way your lungs notice a hill, the way a sidewalk changes texture when you step from shade into sun, the way a familiar corner store has a certain smell when you open the door, the way a commute has its own rhythm, one stoplight that always takes too long, one stretch of road that opens up, a turn where the city suddenly feels quieter. When you say something is a mile away, you don't picture a ruler. You picture a small story, a sequence, a set of landmarks. A mile might mean 2 songs on the radio. It might mean 1 long podcast intro and a few minutes of calm. It might mean the time it takes your coffee to cool from too hot to just right. It might mean crossing a neighborhood, passing the same bakery window, the same bus stop, the same tree that always leans a little toward the street. Even a single block can carry a lot of meaning, not because it's long, but because it's known. You've walked it in different moods. You've walked it in different seasons. You've walked it when you were late and when you weren't. The distance is the same, but the experience changes. And that's what makes it feel real. And when the distance grows, 5 miles, 10 miles, 50, your mind doesn't just add more numbers. It changes the category. A few miles is something you can do without thinking. A few dozen miles is something you plan around. A few 100 miles starts to feel like a small journey, even if the roads are smooth and the car is quiet and the whole thing is comfortable. Because what you're really measuring isn't space. You're measuring effort and time and attention. When someone says, it's about 200 miles, your mind instantly translates it. That's a weekend trip. That's a long drive with a stop for gas. That's arriving with slightly stiff legs. That's a new skyline, a different accent in the coffee shop, a radio station that fades and becomes something else. This is the scale we're built for, not in a poetic way, literally. Your eyes, your muscles, your balance system, your sense of timing, they evolved in a world where distance had consequences you could feel. If you walked too far, you got tired. If you traveled for days, you needed food and shelter. If you crossed a ridgeline, the weather could change, and that mattered. Distance was never an abstract concept. It was practical. It shaped what was safe, what was possible, what was worth doing. So, your brain became excellent at turning space into intuition. It doesn't need perfect accuracy. It just needs usefulness. It needs to know the difference between close enough and too far, between I can make it and I should turn back, between today and not today. And because of that, we rarely notice something important about our normal life. We almost never experience distance as pure distance. We experience it as a chain of moments. A walk is not a line. It's a series of small events. The door opening, the air outside, the first few steps, the sound of traffic, the subtle way your thoughts settle into a rhythm. A drive is not a number. It's merging, breaking, waiting, turning, passing, arriving. Distance is always accompanied by a landscape that changes as you move through it. Even flying, something that should feel like pure distance, still gives your mind a story to hold on to. You check in, you wait, you board, you look out a window. The ground becomes a pattern. Time passes in a cabin with its own quiet rules. And then, eventually, the wheels touch down and you're somewhere else. Your mind loves this. It can anchor the idea of far to a sequence. But now, let's hold on to that insight, because it's going to matter. When we leave the human scale, what disappears first isn't just convenience, it's the landmarks. And without landmarks, distance changes character. It becomes emptiness. It becomes silence. It becomes difficult for the mind to grasp. That's why space can feel so strange. Not because it's complicated, but because it removes the stories your brain normally uses to understand far. Here, on Earth, you can look at a distance and imagine what it would be like to cross it. You can picture the steps. You can picture the hours. You can picture the stops along the way. Out there, between worlds, there are no stops, no roadside, no horizon that slowly shifts as you approach it. Just a dark stretch where nothing changes for a very long time. And that's the moment where a simple word like distance begins to behave differently. Not because your mind is weak, but because it was never designed to hold the kind of emptiness that the universe calls normal. Even when distance gets large, Earth still gives you something the universe rarely offers. It gives you reference points. If someone tells you they drove across the country, you don't need to picture every mile marker to understand what that means. Your mind fills in a story. You imagine long stretches of highway, gas stations glowing at night, a fast food cup in a cup holder, a playlist that runs out and starts repeating. You imagine states changing, time zones shifting, the sky gradually turning a different shade as the hours pass. You might not know the exact number of miles from New York to Los Angeles, but you know what it costs in energy. You know what it costs in patience. You know what it costs in sleep. And that's the key. At this scale, distance is still something you can pay for with a human life. You can cross it with a vehicle, with planning, with a few days of time. It's big, yes, big enough to feel impressive, but it's not the kind of big that breaks your intuition, because Earth is generous in the way it supports imagination. It's covered in shapes and textures and names, mountains, rivers, interstates, cities, coastlines. You can point to the places, you can trace a route, you can say, I've been there, or my friend lives there, or I've seen that skyline in a movie. Every distance on Earth is wrapped in context, and context makes a number feel real. There's another subtle thing too. On Earth, distance is never pure emptiness. Even if you fly for 6 hours over a wide ocean, there's still a planet beneath you, a curved surface, a weather system, a gravity well that holds you. Even when you're above the clouds, you're still inside a world that's full of signals, radio towers, flight paths, satellites, coastlines, a horizon that changes as you move. So your brain can stay relaxed. It can keep building a picture. And that's why it helps to pause here for a moment and let Earth become our last comfortable ruler before the numbers start to slip away from the mind. Consider something simple, the size of Earth itself. If you could walk all the way around the planet at the equator, an impossible stroll but a useful thought, you'd travel about 40,000 kilometers, around 25,000 miles. It's a number that sounds huge, and it is. But notice what your mind does with it. It doesn't freeze. It doesn't go blank. It immediately begins to translate. 40,000 kilometers becomes a map in your head. It becomes continents. It becomes oceans. It becomes stories you already know. Explorers sailing for months, guided by stars and the shape of the coast. It becomes modern flights tracing graceful arcs on a screen. It becomes those thin lines on old globes that show trade winds and shipping routes, like the planet itself is a living thing with patterns of motion. Even if you've never traveled far, you've seen enough images of Earth to have a sense of its wholeness. You've seen the curve. You've seen a satellite photo. You've watched weather swirl across it like breath. So, when someone gives you a planetary number, your mind has something to grab. And if you want to make Earth feel even more tangible, you can zoom into something familiar and build back up. Think about a typical highway speed, 60 miles an hour, 100 kilometers an hour. At that pace, circling the entire planet would take a long time, something like 17 days of non-stop driving. No sleep, no traffic, no fuel stops, no mountains. Just steady motion on an endless road. 17 days is still a number you can understand. Your body knows what 17 days feels like. Your mind knows what it means to be awake too long, to miss home, to crave a shower, to crave your own bed. It's difficult, but not incomprehensible. And that's the pattern on Earth. We can take a big distance and convert it into something our nervous system recognizes. Even time zones work this way. You can leave one coast in the morning and arrive on the other coast when the day feels strangely shifted. It's still the same planet, but your sense of when is nudged by where. That's such a quiet lesson, if you think about it. On Earth, distance and time are always braided together. You travel far enough, and the clock changes. You cross enough space, and your body begins to notice. That relationship between space and time is going to become one of the most important ideas in our whole journey tonight. But for now, on Earth, it still feels gentle. It feels manageable. Even the biggest journeys we take here, crossing oceans, crossing continents, still happen inside a world that is warm enough to hold stories. And that's what makes Earth-scale distance so special. It is the last place where large numbers still feel like something you can live through, where far still has a human shape, where you can say, honestly, that's a long way, and your brain knows what you mean. Because soon, the distances stop behaving like that. Soon, the landmarks vanish, the routes disappear, the comforting surface falls away. And then distance becomes something else entirely, something that isn't measured in road trips or flights or days on a calendar, but in a kind of quiet, endless separation that only the universe seems comfortable with. There's a moment when distance changes its personality. It happens when you look up at the moon and realize you're not looking at a place over there. You're looking at a world that is separated from you by almost nothing at all. Not almost nothing in the sense of being small. Almost nothing in the sense of being empty. On Earth, even the spaces between places are filled with something. Air, weather, streets, sounds, birds, cell towers, smells. You can close your eyes and still feel the world in motion around you. You can always sense the medium you're moving through. But between here and the moon, there is no medium, no highway, no landscape that gradually changes as you approach, no comforting gradient of detail, just a hard vacuum and a wide, quiet gap. And yet the moon is still close enough that the number doesn't feel impossible at first. About 384,000 kilometers. About 239,000 miles. You can say the number, you can even memorize it, but the number isn't what matters. The number is just a handle. What matters is what that distance does to your imagination. Because for the first time, you're dealing with a separation that offers no landmarks. If you tried to picture a line from Earth to the moon, your mind instinctively wants to populate it with something. Clouds, birds, a mountain range, a few stops along the way. But space refuses. It stays empty. And that emptiness is what makes the moon such a perfect threshold for our story tonight. It's where the familiar idea of far begins to feel strange. The moon hangs there like a destination you can see with your own eyes. You can step outside, tilt your head back, and just look at it. You can watch it rise, watch it drift behind branches, watch it wash the ground in pale light. It's intimate in a way the rest of space doesn't seem to be. And that intimacy is deceptive, because even though it looks close, the gap between worlds is so wide that if you placed every car ever made nose to tail across the distance, you'd still be thinking in terms of thousands of miles of metal ribbon stretching through dark. If you tried to cross that gap in a plane, you wouldn't arrive. Not because planes aren't fast, but because fast on Earth is built for air and weather and curved roads. A commercial jet moves at a pace that feels dramatic to a human body. It compresses continents into hours, but to the moon, it would take weeks. And if you tried to do it by car, if you could build a bridge that long, if you could ignore oceans and storms and the simple fact that there's no surface to drive on, your trip would take months. That's the moment the moon becomes more than a pretty disk in the sky. It becomes a measurement of how quickly your intuition runs out. Yet the truly unsettling thing is not how long the trip would take. The unsettling thing is that the moon is, in cosmic terms, still practically next door. The universe has distances that make the Earth-Moon gap feel like a step across a room. And the only reason we can even talk about traveling there, only reason we have a story that makes it feel real, is because we actually did it. Not as science fiction, not as a thought experiment, but as a recorded human event, with hardware and checklists and calm voices speaking into microphones. Apollo, 3 days. That's one of those facts that can sit quietly in your mind for years without fully blooming. 3 days to another world. 3 days to leave your entire planet behind and watch it shrink into a bright marble in a black window. And the speed matters, not for the number itself, but for the contrast it creates. At roughly 11 kilometers per second, those astronauts were moving faster than any normal human experience can prepare you for. Hundreds of times faster than a highway, faster than weather, faster than the rhythms of cities. Their speed had stepped outside the ordinary categories. And still, even at that speed, it took days. Days of coasting through nothing. No scenery changing, no landmarks, no sense of approaching. The way you approach a mountain or a coastline. In space, you can travel for hours and the view barely changes. The destination doesn't slowly get larger in a satisfying way. It waits. It refuses to behave like places on Earth. And then there's the strangest detail of all, so subtle that most people miss it. The moon is close enough that light crosses the gap in just over 1 second. About 1.3 seconds to be more precise. That means the moon you see is almost now, almost present, almost immediate. On a cosmic clock, it is practically touching you. But radio messages have to make the trip too. And in those Apollo recordings, you can hear the pause. That soft, unhurried delay between a question and an answer. Not because anyone is thinking slowly, not because the equipment is weak, but because the universe has introduced a new rule. Information cannot arrive instantly, even at the moon. And when you notice that, something shifts, because that pause is the first whisper of what distance truly means in space. Not just separation of places, but separation of moments. Earth and the moon are two objects sharing the same sunlight, sharing the same night sky. Yet they are already living a second apart, already slightly out of sync, already separated by a small, unavoidable delay. And once your mind accepts that, the next idea becomes easier to hold. That bigger distances won't just be bigger numbers. They will be bigger delays. They will be deeper looks into the past. And the quiet, empty gap to the moon is the first place where that truth starts to feel real. There's an odd trick the sun plays on your mind. It looks close. Not walk down the street close, of course, but close in the way a familiar object feels close. It's there every morning. It follows you through windows. It warms your skin without asking permission. It makes shadows appear and disappear. It paints the day with color, and it does it so reliably that we rarely treat it as a destination at all. It's more like a presence, part of the background of being alive, and that familiarity creates an illusion. Because when you finally try to think about the distance to the sun as a number, something in your intuition quietly slips. The average distance from Earth to the sun is about 150 million kilometers, about 93 million miles. Even if you've heard those numbers before, they still don't behave like normal numbers. They don't produce an image in your head the way 2 miles does. They don't even behave like the Earth-sized numbers we can translate into time zones and road trips. Your brain reads 150 million and understands in a dry, symbolic way that it's large, but it doesn't feel it because there are no landmarks between here and the sun, no coastlines, no cities, no mountain ranges you can slowly approach. Just an open stretch of space so wide that your mind has nothing to attach the distance to, except more numbers. So, let's do what the mind is good at. Let's translate. Suppose for a moment you could drive there. Not in a realistic way, just as a thought experiment. The way you might imagine driving to a distant state and asking, how long would it take? Because time is something your body understands. Time is something you can feel in your bones. If you drove at a steady highway speed, say 60 miles an hour, every hour would give you 60 miles of progress. It's a comfortable rhythm. It's the rhythm of road trips, of coffee stops, of a long day in the car. At that pace, getting to the sun would take well over 170 years. Not days, not months, not even decades. A human lifetime, and then another lifetime, and then another, and then another. You would start your drive before the American Civil War, and you would still be driving today. Generations would pass, languages would shift, nations would change, and the sun would still be waiting, impossibly far away, in a direction your descendants might not even remember why they chose. That's one translation. Now, let's make it faster. Imagine a jet airliner. Commercial jets cruise around 500 to 600 miles per hour, fast enough to cross the country in a morning, fast enough that the world feels smaller. At that speed, the trip to the sun would still take around 18 to 20 years. An entire childhood, a full stretch of adulthood, the time it takes a person to grow into who they are. And even that doesn't really capture it, because a jet doesn't just fly. It lands, it refuels, it needs air to push against. It lives inside the planet's envelope. The sun is not in that envelope. The sun is outside the story Earth normally tells. So, let's try a spacecraft. We know a spacecraft can leave Earth. We have recordings of it. We have photos that prove the journey is real. So, this translation feels cleaner. The Apollo astronauts on their way to the moon were moving at about 11 kilometers per second. That was astonishing speed by human standards, fast enough to make continents feel like small patches on a globe. If you could aim that same kind of speed toward the sun and hold it steadily, the distance would take roughly 5 months to cross. 5 months. That sounds almost reasonable. That's the trap. Because 5 months still fits inside the human imagination. It still fits into calendars and seasons. It still feels like something you could endure with enough supplies, enough planning, enough courage. And yet even that picture is misleading because the Apollo missions weren't built to maintain that kind of speed toward the sun as a sustained cruise. They were designed for a specific arc to a nearby destination with careful fuel limits and gravitational choreography. They were not built for the kind of deep, relentless distance the sun really represents. So, let's choose a more honest example, a probe designed to run fast. The Parker Solar Probe is the fastest human-made object we've ever built. It uses gravity assists, carefully timed flybys of Venus, to fall deeper and deeper into the sun's gravity well, picking up speed like a stone dropped into a deep canyon. At its fastest, Parker moves at well over 100 kilometers per second, so fast that it reshapes what speed means in your mind. It's not just fast, it's alien fast. And still, even Parker doesn't make the Earth-Sun distance feel small in the way you might expect. It doesn't just point at the sun and arrive, it spirals, it falls, it loops, it trades time for safety. It navigates a war zone of heat and radiation, where the difference between survival and failure can be a slight angle, a slight timing error, a small mismatch between the shield and the environment. That detail matters, because it reveals something profound. The sun is not only far away, the sun is difficult. Distance in space isn't just measured in kilometers. It's measured in what the environment does to you as you cross it. And the closer you get to the sun, the more hostile the neighborhood becomes. Not because the sun is angry, but because it's powerful. It is a furnace 1,000,000 miles wide, pouring out energy in every direction. And even at a distance that feels enormous, it's still strong enough to shape your weather, your crops, your oceans, and the chemistry in your own skin. So here is the strange truth. The sun is close enough to feel like part of your daily life, and far enough to make your intuition fail. And that contradiction is exactly why this point in the journey is so important. Because the Earth-Moon distance introduces emptiness. The Earth-Sun distance introduces scale. This is where the numbers begin to lose their familiar handles. Where million is no longer a big pile of something. Where 150 million kilometers becomes a smooth, flat slab of abstraction. Try to picture 150 million of anything. 150 million grains of sand, 150 million seconds, 150 million steps, and you'll notice your mind stops cooperating. It either shrinks the idea until it's manageable, or it gives up and replaces the thought with a vague feeling of very large. That's what the sun does to our brains. It forces the mind to admit that its normal tools were made for a smaller world. And the universe has a gentle solution for that. Not by inventing more complicated math, but by changing the ruler. Because once distances get this large, we need a measurement that isn't built around roads or wheels or even rockets. We need a measurement that belongs to space itself. Something that can cross that emptiness effortlessly. Something that doesn't need fuel or air or gravity assists or years of careful planning. And there is only one thing that does that naturally. Light. Light moves through the same emptiness that confuses our intuition. And it does it as if the emptiness isn't even there. It crosses the Earth-Sun gap in minutes. It crosses the Earth-Moon gap in seconds. It doesn't get tired. It doesn't slow down. It doesn't take detours. So, if we want to understand distances that are beginning to break our brain, we don't start with cars or planes. We start with the one traveler the universe built to handle the dark. And once you adopt that traveler as your ruler, distance becomes something you can finally hold again, quietly, clearly, without your intuition slipping away. Imagine you're trying to explain the size of the ocean to someone who has only ever lived beside a small lake. You can give them numbers, depth, miles of coastline, total volume, but the numbers won't do the real work, not by themselves. Numbers are clean, but they're cold. They don't automatically turn into intuition. What the mind really wants is a reference that belongs to the scale you're describing. And once you start thinking about the universe, you begin to notice something quietly strange. Almost everything we use to measure distance is built for Earth. Miles and kilometers were made for walking, for roads, for borders, for maps. Even the most modern versions, GPS coordinates and satellite imagery, still assume a planet with a surface and a traveler who moves slowly across it. And even when we try to upgrade, when we use rockets and probes, we're still thinking like Earth creatures. We measure by fuel, by speed, by travel time. But space doesn't care about our fuel. It doesn't care about our engines. It doesn't care about what we consider fast. Space offers a different kind of ruler, a ruler that doesn't need roads, a ruler that doesn't need air, a ruler that is so fundamental that even the universe seems to treat it like a boundary line. Light. Light is the only traveler that moves through the emptiness as if the emptiness isn't a problem. It doesn't have to push against anything. It doesn't have to carry propellant. It doesn't slow down because the space between worlds is wide and quiet and dark. It simply goes. And that's why, at some point, astronomers stop trying to measure the cosmos the way we measure a road trip. They do something much more natural. They let light become the yardstick. Because light is already doing the traveling for us. Every time you look up, you're receiving information carried by light. Information that crossed a gap you could never cross with your body. You don't have to imagine the distance the way you imagine a drive. The distance is already expressed in the one form that makes sense at cosmic scale. How long did the light take to get here? That question turns out to be one of the cleanest questions you can ask in astronomy. It's almost poetic, but it's also brutally practical. How long did it take? Because in space, time, and distance don't separate neatly. They braid together. If something is far away, it's not just far in space. It's far in information. It's far in news. It's far in what you can know right now. And light is the messenger. There's another reason this works so well, and it's one of the great quiet facts of physics. Light doesn't just move fast. It moves at a speed that seems to be stitched into reality itself. No matter how you chase it, no matter how you measure it, the speed of light stays the same. It behaves less like a normal speed and more like a rule, like a limit the universe insists on. A kind of cosmic speed limit that isn't negotiable. That might sound like an odd thing to say because in everyday life, speed is always relative. You can jog next to a cyclist and still feel the difference. You can fly east or west and notice the time change. You can add speeds together. But light refuses to play that game. It's as if reality has decided that light will always be the same kind of fast, no matter who is watching. And that stubborn consistency makes it incredibly valuable as a ruler. If you measure distance using cars, planes, or rockets, your ruler changes with technology. Your ruler improves. Your ruler gets faster. Your ruler is a human invention. But if you measure distance using light, you're measuring with something the universe provides. Something that doesn't change because your engines got better. Something that doesn't care whether it's 1905 or 2025. Something that behaves the same in empty space, near a planet, near a star, near the edge of a galaxy. Light becomes the one ruler that's fair everywhere. And once you accept that, a few beautiful comparisons begin to fall into place. Think of how fast light is compared to what we call fast. A car at highway speed covers a mile in about a minute. A jet covers a mile in a handful of seconds. A spacecraft can cover a mile in less than a blink. But light can circle Earth more than 7 times in a single second. That's not a dramatic statement. It's a kind of quiet shock. If you could paint a glowing ring around the equator and watch a photon race along it, it would make lap after lap before your brain even finished reacting to the idea. If you tried to track it with your finger, you'd fail. If you tried to imagine it as a moving object like a car, you'd have to let go of the image immediately because it would be gone before the image could form. And this is why the cosmic ruler has to be light. Because the distances out there aren't just bigger versions of Earth distances. They're different in character. When a distance becomes so large that even the best human machines take decades, centuries, or longer, the word travel stops being useful. The emotional meaning of going there dissolves. It becomes less like a trip and more like an era. But light doesn't have that problem. Light doesn't experience a road trip. It doesn't experience boredom. It doesn't need rest stops. It doesn't need to be protected from the environment. It simply spans the gap. So instead of saying, how many miles away is that star? Astronomers say, how long does light take to cross the gap? And suddenly the distances start to behave again. They become understandable in a different language. A language built around signals. A language built around delays. A language built around the most basic transaction in the universe. Information moving from one place to another. Once you start thinking this way, you notice how deeply it changes the meaning of seeing. On Earth, seeing feels immediate. You look at a tree and assume you're seeing it now. You look at a friend and assume the face in front of you is perfectly current. And at human scale, that assumption is close enough to true that we can treat it as true. But the moment you use light as the ruler, you realize that every act of seeing includes a delay, a small one, a nearly invisible one, but it's there. When you look at the sun, you are not seeing the sun now. You are seeing light that left it minutes ago. When you look at the moon, you are seeing light that left it more than a second ago. And when you look at a star that is light years away, you are looking at something that happened years ago. Light makes that unavoidable. It turns seeing into a time machine, not because of science fiction, but because of a simple rule. Information takes time to travel. And the faster your messenger, the cleaner your ruler. That's the deeper reason light becomes the measure, not just because it's fast, but because it's the carrier of reality's updates. The way the universe tells one region of space what another region is doing. So, when we talk about a light year, we're not just inventing a dramatic sounding unit. We're admitting something honest. We're saying, at this scale, distance is best understood as a delay. A delay between an event and your awareness of it. A delay between a change and your ability to know it. A delay between cause and effect across the dark. And that is a very different way to think about space. It's also a strangely calming way, because it means the universe isn't silent. It's simply slow to speak across vast emptiness. And light is the voice. The one voice that travels faithfully without changing its pace, carrying the story of distant places into your eyes. Once you accept that, you're ready for the next step. Not the emotional idea of distance, not the travel time thought experiments. The clean definition, the precise meaning. What a light year actually is. When you translate it all the way down to a number your calculator can write, even if your intuition still struggles to hold it. There's a small misunderstanding that clings to the phrase light year, almost like static. It sounds like time. The word year is sitting right there in the name, so the mind does what the mind always does. It translates instantly. It assumes we're talking about duration, about how long something lasts. But a light year is not a stretch of time. A light year is a distance. It is a way of saying, very plainly, if light left here and traveled for 1 year at its usual pace, how far would it go? That's all. No science fiction, no shortcut, no metaphor. Just a ruler built from the one messenger the universe actually uses. And once you hear it that way, the unit becomes almost comforting because it's honest. It doesn't pretend the distances are friendly. It doesn't squeeze them into miles and hope your intuition follows. It simply accepts the scale and chooses a ruler that belongs to it. So, let's define it with calm precision. First, you need the speed of light. In vacuum, through empty space, light moves at about 300,000 kilometers per second. More precisely, it's 299,792 kilometers per second. But for the purpose of intuition, 300,000 is beautifully close. And it already tells you something startling. In a single second, light can cross a distance large enough to wrap around Earth multiple times. Now, if a light year is how far light travels in 1 year, we just have to translate a year into seconds. A day has 24 hours. Each hour has 60 minutes. Each minute has 60 seconds. So 1 day has 24 times 60 times 60 seconds. That's 86,400 seconds in a day. Now, multiply by the number of days in a year. If we use 365 days, we're close enough for the feeling to land cleanly. So 1 year has 86,400 times 365 seconds. That comes out to 31,536,000 seconds. Just over 31 million seconds in a year. Now comes the simple part. If light travels about 300,000 kilometers every second, and there are 31,536,000 seconds in a year, then in 1 year, light travels 3,700 kilometri secunde, reis 3,000 milhões pieci, 3,006 sekundes. When you multiply that out, you get 9,460,800,000,000 kilometers. That's 9.46 trillion kilometers. And if you prefer miles, it's about 5.88 trillion miles. That number is so large, it almost stops behaving like a number. Not because it's complicated, but because it has nowhere to live inside a human mind. You can say it, you can write it, you can store it in memory, but you can't easily picture it. And that's exactly why the unit exists in the first place. A light year is astronomy admitting something gentle and true. Kilometers aren't wrong, they're just not helpful anymore. Because if you try to talk about stars in kilometers, you end up with numbers that are technically precise and emotionally meaningless. You get a long row of digits that doesn't connect to anything your life has ever experienced. But if you say 4 light years, your mind can at least hold the shape of it. 4 years of light travel. 4 years of reality's message moving through the dark. 4 years of distance, expressed in the only language the cosmos actually speaks fluently, the language of signals. Now, this is the place where the misunderstanding often returns, so it's worth saying again, slowly, clearly, and without embarrassment. A light year is not the amount of time it takes to travel somewhere. It is a distance equal to how far light travels in a year. So, if a star is 4 light years away, that doesn't mean it's 4 years old. And it doesn't mean time behaves strangely around it by default. It means the distance is so large that the most natural way to express it is in terms of light's travel. And because light is also how we see, the definition immediately carries a second meaning, one that feels almost eerie when you first notice it. If a star is 4 light years away, the light entering your eyes tonight left that star about 4 years ago. So a distance becomes a delay. A ruler becomes a clock, not because we decided to turn it into 1, but because the universe already did. That's the deeper elegance of the light year. It measures distance in a way that automatically reminds you of the cost of distance, time. Not time as a poetic idea, but time as a hard limit on information. The universe has speed limits not because it wants to be difficult, but because cause and effect need structure. If information could arrive instantly from anywhere, the idea of here and there would blur into nonsense. Reality would lose its order. So distance has consequences, and the light year is simply the cleanest way to keep those consequences visible while you talk about the stars. There's another reason astronomers like this unit, and it's quietly practical. When you say 9.46 trillion kilometers, the number feels absurdly specific, even though no one is actually navigating a road trip. It suggests a precision that the human mind can't use. But when you say 1 light year, you're making the scale readable. It becomes easy to compare. 2 light years is twice as far as 1. 10 light years is 10 times as far. 100 light years is suddenly a meaningful neighborhood in a galaxy. And even though the numbers are still large, they become proportional, which is how intuition prefers to think. The human mind is not built to love absolute magnitude. It loves ratios. It loves, this is twice as far, or this is 10 times as far, or this is so far it changes the rules. The light year supports that kind of thinking. It also supports a kind of quiet humility, because when you define distance using light, you're defining it using the fastest messenger you know, the best case, the cleanest traveler, the one thing that crosses the void without effort. So, if light takes years to get somewhere, you immediately understand that no ordinary vehicle is casually doing the trip. A light year gently tells you, this isn't a place you visit, this is a scale you respect. And that respect is not meant to frighten you, it's meant to clarify. Because once you accept the true size of the distances, you stop forcing your mind to pretend. You stop trying to squeeze the universe into human categories. You let it be what it is. And the reward is that the night sky becomes more honest, and strangely more intimate at the same time. Because the stars stop being decorations. They become communications. They become history arriving on schedule. Every point of light becomes a message that has been traveling longer than most human plans. Longer than most human worries. Longer than most human lives. And a light year in that sense is not just a measurement. It's a reminder that the universe is connected, just not instantly. Connected by delay, connected by travel, connected by a constant stream of light that never stops moving, never stops reporting, never stops carrying reality from one region of space to another. So, when you hear light year, try to hear it the accurate way. Not as time, as a distance so large that the only reasonable ruler is the one thing that can actually cross it with ease. 1 year of light, about 9.46 trillion kilometers. And the moment you accept that number as a real distance, whether your mind can picture it or not, you've taken the first step into the cosmic scale that the word was made for. Here's a quiet thought that changes the way distance feels. You never see anything in the present, not perfectly. In everyday life, the delay is so small that we can ignore it. When you look at your hand, the light reflecting off your skin takes a tiny fraction of a second to reach your eyes. Your brain stitches it together so smoothly that it feels immediate, instant, real time. But the universe doesn't actually work in real time. It can't, because information has to travel, and the universe delivers information the same way it delivers everything else, through physical messengers, through photons, through light. Which means every time you look at anything, you're looking at a message that left that thing a moment ago. Usually that moment is so small it doesn't matter. Until it does. Start with something simple and close. The moon. Light takes just over a second to cross the gap between Earth and the moon, about 1.3 seconds. So the moon you see is the moon, as it was a little more than a second ago. That doesn't feel dramatic. A second is nothing. Your mind treats it like nothing. But notice what just happened. Distance turned into time. Not philosophically, not metaphorically, literally. The moon's distance is a delay. And once you notice that, you can't unnotice it. Because now the sun becomes even more interesting. When you look at the sun, please don't do it directly, of course, but you know what I mean. When you see sunlight, or feel its warmth, or watch it pour through a window, you are not experiencing the sun right now. You are experiencing the sun as it was about 8 minutes ago. More precisely, sunlight takes about 8 minutes and 20 seconds to reach Earth. That means the light touching your face this morning began its journey while you were still doing something else. While you were pouring coffee, or turning a page, or waking up slowly, the sun was already sending those photons out. They traveled through empty space for more than 8 minutes, and only then did they arrive at you. That sounds like trivia at first, one of those facts you might hear in a classroom and nod at. But if you let it settle, it becomes strangely intimate. It means you are always living slightly behind the sun. Not in a tragic way, in a gentle physical way. In the same way you hear thunder after you see lightning. The event happens, and then the message arrives. And suddenly, the universe feels less like a static scene, and more like a stream of updates arriving with built-in delays. And those delays aren't a flaw. They are the rule. Because the speed of light is not just fast. It's the fastest speed information can travel. It's the speed limit for cause and effect. If something happens on the sun, if a flare erupts, if a region brightens, if something changes in a way that could matter to us, the earliest we can possibly know is after that 8-minute message crosses the gap. Even if you had the best telescope ever built, pointed at the sun constantly, you could not beat the delay. Reality itself won't allow it. So distance becomes time, and time becomes a kind of built-in patience. The universe is teaching you quietly that now is local. Now belongs to your region of space, and every other region of space has its own now, separated from yours by travel time. This is where the idea of a light year starts to feel more than just a unit. Because once distance becomes delay, the phrase 4 light years away suddenly has a second meaning you can't avoid. It means the light takes 4 years to get here. So the information you're receiving is 4 years old. You are not seeing a star as it is. You are seeing a star as it was when the light began its journey. And the deeper you push into space, the deeper you push into the past. This is why astronomers sometimes say the universe is a time machine. Not because it lets you visit the past, but because it forces you to observe the past whenever you look far away. The past isn't hidden. It's simply distant. Even the moon is a little late. Even the sun is late by minutes. And when you look at the stars, late becomes years, decades, centuries, and more. Now, there's a subtle emotional shift that happens here. And it's part of the reason this topic is so strangely calming when you let it unfold slowly. Because it changes the way you interpret what you're seeing. If you look up and see the sun glowing in a bright blue sky, it feels like a constant, like a stable, immediate presence. But in truth, you're seeing the sun's past, a version of it that existed 8 minutes ago. And 8 minutes isn't much, but it's enough to reveal the rule. The cosmos does not deliver anything instantly. It delivers by travel. It delivers by delay. And once you accept that, The night sky becomes less like a ceiling and more like a library. Every point of light is a page that has been traveling toward you. Some pages are almost current, some are very old, but all of them are real messages from real places, arriving with a timestamp built into their journey. The moon teaches this lesson softly, in seconds. The sun teaches it in minutes. And those two examples matter, because they create a bridge your intuition can actually walk across. You don't have to jump straight to light years to understand what a delay means. You can feel it already in the everyday world. You can feel it every time you watch a live broadcast from far away and notice the tiny lag. You can feel it when you FaceTime someone across the planet and the audio arrives a fraction late. You can feel it when you click send and the message doesn't arrive instantly, even though it feels like it should. Those are small echoes of a deeper rule, because the universe is doing the same thing, just on a scale so large that we had to invent new words to talk about it. And there's one more detail that ties it all together, something that's both scientific and oddly poetic. The light that reaches you from the sun is not special light. It's not a different category of messenger. It's the same kind of photon that bounces off your wall lamp, or flickers from your phone screen, or reflects off the pavement at night. The universe isn't using a magical channel to communicate with you. It's using the simplest thing it has, light, which means that when you look at the world, when you look at anything, you are always receiving a little story from the past, a tiny delay, a tiny distance turned into time. Most of the time, it's so small you can ignore it. But once you start talking about space, you can't ignore it anymore. Because out there, delay isn't a detail. It's the entire meaning of distance. And when you finally let that sink in, the idea of a light year becomes more than a number. It becomes a way of saying, this is how long reality takes to reach you. In the late 1600s, long before rockets, before radio, before anyone could imagine a camera in orbit, there was a simple frustration that kept showing up in the night sky. Astronomers were watching Jupiter, not because Jupiter was mysterious in the modern sense, but because it was dependable, it was bright, it was easy to find, and it had little moons that moved with clock-like regularity, tiny points of light that slipped into Jupiter's shadow, disappeared, and then returned again. Those disappearances were useful. If a moon goes dark at a predictable moment, you can treat it like a ticking hand on a celestial clock. One of the people who took this seriously was Ole Rømer, a Danish astronomer working in Paris. He wasn't trying to write poetry about Starlight. He wasn't trying to solve the grand meaning of the cosmos. He was trying to make measurements that actually held steady. So he did what careful scientists often do. He watched and he wrote down times. Over and over, each eclipse of Jupiter's moon, Io, one of the easiest to track, went into his records. At first, the timings looked comforting. The moon vanished, reappeared, vanished, reappeared, a rhythm you could trust. But then something quietly wrong began to appear. The same kind of event, Io slipping into shadow, didn't happen at exactly the same predicted time every cycle. Sometimes it was early, sometimes it was late. Not wildly, not enough to scream, something is broken. Just enough to be irritating if you were trying to treat it like a perfect clock. And that's where the story becomes surprisingly human. Because when a measurement doesn't fit, you have two choices. You can assume your instrument is flawed, or you can assume nature is telling you something new. Rømer noticed a pattern. The late eclipses tended to happen when Earth was moving farther away from Jupiter in its orbit, when the gap between the two planets was stretching, and the early eclipses tended to happen when Earth was moving closer, when the gap was shrinking. If light arrived instantly, none of this should matter. The eclipse happens at Jupiter, you see it at Earth. End of story. Distance wouldn't shift the schedule. But if light takes time to travel, if the event happens first and the message arrives later, then Earth's changing position would matter a lot. When Earth is farther away, the light has a longer journey and the eclipse appears delayed. When Earth is closer, the journey is shorter and the eclipse appears sooner. It's a simple idea now, but at the time it was daring, because for many people, light felt instantaneous by common sense. You open your eyes and the world is there. You strike a match and the flame appears. It doesn't feel like something that travels. Raymer treated light as a traveler anyway. He proposed that the reason the timings were drifting wasn't because Io was misbehaving, and not because the math was sloppy, but because the signal itself, the light, needed time to cross the changing space between worlds. And he went further. He made a prediction. If Earth kept moving into a position where it was farther from Jupiter, the eclipses would keep appearing later, and later compared to the schedule. Then, on a specific occasion, he publicly predicted that an eclipse would occur about 10 minutes later than other astronomers expected. And when the night arrived, the sky delivered its quiet confirmation. The eclipse came late, not because the moon changed its mind, because the information took time. That moment matters more than it might seem. Because it was one of the first times in history that humans had evidence, real evidence, that light is not infinite in speed, that seeing is not instantaneous, that the universe has a built-in delay between events and awareness. In other words, distance had consequences. A gap between worlds wasn't just empty nothingness. It was a medium that demanded patience. The message had to cross it. And once that idea exists, everything else in astronomy changes with it. The sky stops being a fixed mural and becomes a stream of signals arriving on schedule, sometimes late, sometimes early, depending on how far they had to travel. A light year, in a sense, is the grown-up version of Roemer's discovery. It's the same principle, simply scaled up until the unit itself becomes time-shaped. Not because distance is time, but because distance creates time whenever information has to move. So, when you hear that light years are how astronomers measure the stars, you're also hearing an echo of a winter night centuries ago. One careful observer, one stubborn set of timings, and one calm realization. Light does not arrive instantly. It arrives, it travels, it takes its time, and the universe patiently makes us wait for the truth to reach us. There's a moment in any space documentary where a narrator says a number that sounds impressive, and then it slips right through your mind. 1 million, 1 billion, 1 trillion. They all start to feel like the same word. Huge. And that's not because you're not smart. It's because your brain wasn't built to live with numbers like that. Your brain was built to live with paths you can walk, roads you can drive, and distances that have texture, corners, lights, signs, familiar buildings, the feeling of almost there. 1 trillion has none of that. So if we want a light year to feel real, if we want the phrase to stop being a vague sci-fi sound, we have to do something a little different. We have to make trillion behave like something human. One of the simplest tricks is to use time, because time is the one big thing you've actually experienced every day of your life. So imagine counting, not in a dramatic way, not as a stunt, just quietly, steadily. 1 number per second. 1, 2, 3. 1 million seconds is about 11.5 days. That's not abstract. That's a couple of weeks. That's enough time for habits to shift a little, enough time for weather to change, enough time for you to forget what you ate on day 1. 1 billion seconds is about 31.7 years. Now we're in a different emotional category. 1 billion seconds is a whole childhood. It's high school memories fading. It's people you haven't seen in decades. It's music eras changing. It's a life chapter. And here's where the mind starts to wobble. Because we just jumped from a couple of weeks to 3 decades by changing one word. Million to billion. Now take one more step. 1 trillion seconds is about 31,700 years. Let that settle. 31,700 years is longer than recorded history as most of us think of it. It reaches back beyond the pyramids, beyond ancient Greece, beyond Rome, beyond the earliest chapters you learned in school. It's closer to the world of cave paintings and mammoths than it is to your own life. And that's seconds. That's not miles, not kilometers, not space, just seconds. So, when you hear 9.46 trillion kilometers for a light year, the problem isn't that you don't understand the math. The problem is that your brain doesn't have a grip strong enough to hold trillion, the way it holds 10 or 100 or even 1 million. It's like trying to hold water in your hands. It feels like you understand it, and then it leaks away. So, here's another way to make it stick. Picture a long highway drive, one of those stretches where the road is straight, the scenery repeats, and the distance feels real because your body is paying for it with time. Now imagine a mile. If you drove a mile a minute, 60 miles per hour, then 1,000 miles would be about 16 to 17 hours of driving. That's a full day of effort. That's gas stops and fatigue and the feeling of the world slowly sliding by. Now imagine 1,000,000 miles at that same speed. At 60 miles an hour, 1,000,000 miles would take you about 1,666 hours, which is roughly 694 days. Almost 2 years of non-stop driving. 2 years without sleeping, without stopping, without eating, just the wheel and the road. Already, it's ridiculous. Not because the number is impossible, but because the effort becomes meaningless. Now, take 1,000,000,000 miles. At 60 miles an hour, 1,000,000,000 miles would take you about 1.9 million years. 1,000,000,000 miles becomes geological time. It becomes the kind of number that belongs to rocks, not people. And a light year is not 1,000,000,000 miles. A light year is about 5.88 trillion miles, or 9.46 trillion kilometers. That's not a lot. That's beyond travel in the way we usually mean it. And this is exactly why the universe forces us to invent new intuition. Because at these scales, your everyday mental tools break. Your brain keeps searching for landmarks, and there are none. It keeps searching for a familiar unit, and it doesn't fit. So, we anchor it to the one thing that stays steady everywhere. Time. A light year is the distance light travels in 1 year, and light travels about 186,000 miles every second, which means in the time it takes you to inhale slowly, light has already crossed a distance that would take a jet hours. In the time it takes you to blink, light has already covered tens of thousands of miles. And in 1 year, one ordinary year of days and nights, light travels a distance so large that our language begins to feel too small. This is why astronomers talk the way they do. When they say a star is 4 light years away, they're not just saying it's far. They're giving you a translation your brain can actually use. The message takes 4 years to arrive. That star is 4 years of travel away at the fastest speed the universe allows. And the quiet, unsettling consequence is this. If trillion is too big to feel, then years becomes the handle. It becomes the hook your mind can hold on to. Because you know what a year feels like. You've lived through winters and summers. You've watched calendars turn. You've felt the way life changes in 12 months. So, the word year turns a cosmic distance into something your nervous system recognizes. Not fully, but enough. And there's one more little perspective shift that makes trillion even stranger in a gentle way. We often talk about numbers as if they're just labels. But a trillion isn't just a big number. A trillion is the point where scale stops being intuitive and becomes structural. It changes what's possible. At 1,000, you can still picture a crowd. At 1,000,000, you can picture a stadium full of stadiums, and you can sort of nod along. At 1,000,000,000, you start relying on metaphors. At 1,000,000,000,000, you're no longer picturing. You're admitting this belongs to the universe, not to my senses. And that's not a weakness, that's honesty. Because your brain is a small, brilliant piece of biology that evolved on a planet only so wide. It learned distance the way you learn a room in the dark, by touch, by repetition, by experience. But the cosmos isn't a room, it's an ocean with no shore. And trillion is the first time the ocean becomes so wide that you can't pretend you'll ever swim it. So, when you hear 9.46 trillion kilometers, the goal isn't to picture it perfectly. The goal is simply to recognize what kind of number it is. It's the kind of number that tells you, your instincts are no longer in charge. A new ruler is needed, and that ruler will be light, because light doesn't care if a number is too big. Light just travels, patiently, steadily, and it turns the unimaginable into something measurable, 1 second at a time, 1 year at a time, until even the word trillion starts to feel less like a blur, and more like a doorway into the true scale of space. Try something small and precise for a moment. Not a trillion, not a light year, just 1 second. Because a light second is the first rung on the ladder where the universe begins to feel different. In 1 second, Light travels about 300,000 kilometers. That number is already larger than most people realize, because a second feels like nothing. A blink, a quiet breath, a tiny pause between thoughts. But in that tiny pause, light can circle the Earth more than 7 times. It's hard to carry that in your head, because your life is full of seconds that don't seem to do much. Seconds are where we stall at a red light, where we hesitate before replying, where we look down at a phone screen, and yet the universe treats a second like a highway. So, when we say light second, what we're really doing is trading a distance your brain can't picture for a time your body understands. A light second is also a good place to notice something quietly profound. At cosmic scales, fast isn't a personality trait. It's a physical law. Nothing carries news faster than light. Nothing delivers what happened any sooner. If something changes, if something flashes, if something explodes, the universe does not rush to tell you. It simply sends the message at the one speed it allows, every time. Now, let's stretch that second into something still gentle, but more meaningful. A light minute is about 18 million kilometers. That's the kind of number that would usually bounce right off your mind. But as a minute, it becomes a feeling. A minute is a small wait. A minute is the hold on you say to someone in the next room. A minute is the time it takes water to start to warm, or a microwave to hum, or a kettle to think about boiling. In that ordinary minute, light crosses 18 million kilometers. So, if you could watch a beam of light leave Earth and keep going, 1 minute later, it would already be far beyond anything we've ever touched with our hands. Far beyond any airplane, far beyond the reach of any road. And still, it would feel like it had barely started, because the ladder is built to humble you. Now, there's a distance you've probably heard so many times it has almost become a slogan. The sun is about 8 light minutes away. Not 8 minutes by spaceship, not 8 minutes by rocket, 8 minutes by light. That means the sunlight warming your skin began its trip before you were in the exact moment you think you're in right now. It left the sun and crossed space while your life continued normally, while you took a sip of water, while you shifted in your chair, while you blinked. If the sun vanished this instant, if it could, as a thought experiment, the bright blue sky would not immediately go dark. Gravity would not immediately loosen its grip. The world would not instantly notice. There would be a calm, ordinary delay, about 8 minutes of normal life, and then the message would arrive. That little idea is one of the most important emotional pivots in this entire topic, because it gently teaches you that distance is not just space. Distance is delay. Distance is waiting. Distance is the gap between an event and your awareness of it. And once you understand that, the night sky stops being a view. It becomes a timeline. Now let's keep climbing, still in human steps. If 1 light minute is already enormous, then 8 light minutes should feel almost unbelievable. But here's the strange thing. Your brain starts to adapt, not by perfectly imagining the distance. It can't. It adapts by learning the relationship. 8 minutes becomes the handle you can hold. And once you have that handle, you can begin to compare. Because comparison is how the mind survives large numbers. So, compare light to the fastest things we've built. A passenger jet cruises around 900 kilometers per hour. A fast rifle bullet might travel about 1 kilometer per second, give or take. Even the fastest spacecraft we've launched, at their peak speeds, are still crawling compared to light. Spacecraft speeds feel impressive because space is empty and we are small. But next to light, they are gentle. Light is not fast. Light is a different category. And that's why space travel becomes so psychologically difficult the moment you leave the Earth-Moon neighborhood. In the Earth-Moon neighborhood, you can still tell stories in days and hours. You can still feel the rhythm of the journey. But once your distances are naturally measured in light time, you begin to realize something that sounds simple, yet changes everything. Even if you could go incredibly fast, you still wouldn't go fast enough. And the universe will make you prove it with patience. Now, let's bring this down from poetry into a situation that feels very practical. Mars. Mars is close enough to feel like a destination humans might actually reach in the future. People talk about it like a next chapter of exploration, a place with hills and dust storms and sunsets. But Mars teaches a brutal lesson about distance without being cruel about it. Because Mars is far enough away that you cannot drive a rover in real time. You can't sit at a joystick on Earth and steer a rover like a little remote control toy. The reason is simple. The radio signal is limited by the speed of light. Depending on where Earth and Mars are in their orbits, the one-way communication delay is roughly a few minutes to over 20 minutes, often described as about 4 to 24 minutes, with typical working ranges commonly cited around 3 to 22 minutes. However you slice it, it's long enough to break the illusion of remote control. If you send a command and wait for confirmation, you are waiting through a quiet chunk of your life. And if you make a mistake, you don't correct it instantly. You correct it after the delay, and then you wait again. So what do engineers do? They don't drive, they plan. They create sequences. They send careful packets of instructions. Move this far, turn this angle, take a picture, check for hazards, stop if something looks wrong. It's less like steering a car, and more like sending a very patient, very polite letter to a robot. And here's the part that sounds almost tender if you let it. The rover becomes a little more independent because the universe forces it to be. Distance doesn't just make travel harder. Distance reshapes behavior. It changes how we control things, how we coordinate, how we think. On Earth, we're spoiled by immediacy. We do video calls, we play online games, we expect a response so fast, we interpret delays as broken. Even a half-second lag can feel irritating. But Mars makes you accept a different rhythm, a slower rhythm, a rhythm where now is local, not universal, where I did it and you saw it are separated by space. And once you accept that rhythm, you begin to see why the universe feels so quiet. Because conversation itself is expensive, even in our own solar system. Now, climb one more rung, a light hour. A light hour is about 1.08 billion kilometers. That number is enormous, but again, the time unit helps. An hour is familiar. An hour is a movie. An hour is a late-night conversation. An hour is what you bargain with when you say, just give me an hour. And in that single hour, light covers more than 1 billion kilometers. This is where the solar system starts to feel like what it truly is. Not a neat model with planets spaced politely apart, but a wide, mostly empty realm where the important thing isn't what's there. It's the space between what's there. When you think about the outer planets, Jupiter, Saturn, people often imagine them like stops on a road trip. But a light hour reminds you that there is no road. There's only time and emptiness. And the outer solar system is far enough away that when something happens out there, you don't get it instantly. You get it later, long after the moment has passed. If a spacecraft near Saturn takes a picture and sends it home, the picture arrives after a delay that can be around an hour or more, depending on where everything is. It's not a live broadcast. It's a message in a bottle. And this changes how you imagine exploration. We like to picture a person seeing something and reacting right away. But at these distances, reaction becomes delayed. Discovery becomes delayed. Even excitement becomes delayed. A team can schedule an event, send a command, and then wait. They can watch a clock and know, calmly, that the signal is crossing darkness at the fastest speed reality allows. They can know that the spacecraft has already done the thing. But they won't know it yet. That difference between what has happened and what you are allowed to know is one of the quiet themes of space. It's also the beginning of why the phrase light year is so powerful. Because light time is not just a measurement, it's a boundary. It's the limit of coordination, the limit of control, the limit of togetherness. A light second still feels playful. A light minute feels impressive. 8 light minutes begins to feel philosophical. Mars makes it practical. A light hour makes it emotional in a subtle way. Because once delays become an hour, you can feel what it would mean to be truly far from home. You can feel the loneliness that isn't dramatic. Just structural, not sadness. Just distance doing what distance does. And the ladder keeps going, from seconds to minutes to hours. You've already watched the universe teach you its rule. If you want to reach farther, you don't just need better engines. You need patience. You need planning. You need a willingness to live with delay. And for a moment, if you let it, that can be oddly calming. Because it suggests that the universe is not in a rush. It's vast and steady and indifferent in the gentlest possible way. It doesn't hurry. It simply allows messages to travel, 1 second at a time, 1 minute at a time, 1 hour at a time. And somewhere beyond this rung, beyond the hour, the distances start to become so wide that a trip turns into something else entirely. Something you measure in days of light, in weeks of light, and the kind of waiting that changes what the word far even means. Now the latter starts to feel less like a set of measurements and more like a change in perspective. A light day is the distance light travels in 1 full day and night, 24 hours of steady motion at the fastest speed reality allows. That's about 25.9 billion kilometers. It's an absurd number if you try to hold it as kilometers. Your mind has nowhere to attach it, no mental landmarks, no familiar route, no sense of how far that feels. But as a day, it becomes a rhythm you already live inside. A day has weight. A day has a beginning and an end. A day is the time between waking and sleeping, between a morning and a night. And the moment you use that rhythm as your ruler, your imagination becomes much calmer. Because now you're no longer asking your brain to picture a giant number. You're asking it to picture waiting. A light day is the distance you cover if you send a message today and it arrives tomorrow. It's the scale where space stops looking like a diagram with dots and becomes something more honest. A place where the empty part is the main feature. When people think about the solar system, they often imagine it like a neat model on a classroom table, a bright lamp for the sun, and little planets spaced out politely. It's tidy, it fits, it feels like a neighborhood. But a light day quietly breaks that illusion. Because the solar system isn't a neighborhood. It's a set of tiny islands in a dark ocean. And a light day is the kind of ruler you use when the ocean is the point. This is also where you begin to understand what space missions really are. We like to picture spacecraft as if they're on an adventure, like a car heading down a long highway. But in reality, once a spacecraft leaves Earth behind, it spends most of its existence moving through nothing. Through blackness so empty, it doesn't even feel like a place. There are no gas stations, no mile markers, no scenery. Just time, and signals, and patience. That's why, as missions go farther out, the relationship between Earth and the spacecraft changes. It becomes less like a driver and a car, and more like a distant partnership. You send instructions and you wait. The craft does its work out there in silence, and then you wait again. The photos, the data, everything arrives like a delayed echo. Not because anyone is slow, because the universe is large. Now, a light day also helps you feel a famous story in a different way. Voyager. Voyager feels like a legend because it is one. 2 small spacecraft launched in the 1970s, still sailing outward, still sending back whispers from beyond the planets we grew up hearing about. But here's the calming reality that the latter reveals. Even Voyager, for all its lifetime of travel, is still close by cosmic standards. Voyager has been traveling for decades, and yet, if you measure space with light time, it's still in a range that feels surprisingly intimate. When you hear people say that Voyager is light hours away, or light days away, it doesn't sound like the edge of the universe. It sounds like the far end of a very large house. And that contrast is the whole point of this ladder. It teaches you that the solar system is massive compared to us, and still tiny compared to the distances between stars. So, when you step from light hour into light day, you're not just learning a measurement. You're preparing your intuition for the next leap. Because the next leap is where things start to get emotionally strange in the best way. A light week. A week is familiar, almost comforting. A week is a work schedule. A week is, see you next weekend. A week is the time it takes to feel like something has changed, even if nothing dramatic happens. And in that familiar span, light travels about 181 billion kilometers. That's not just far. That's your brain stops pretending it knows what far means. You can still say the number, you can still write it down, but you can't feel it. So again, you don't try to feel the kilometers. You feel the waiting. A light week is the distance a message travels while you live through a full week of ordinary life. You go through meals and errands and sleep and mornings and a little boredom and a few small surprises. And somewhere out there, a signal is still moving through darkness. If you sent a hello across a light week, the reply wouldn't be quick. It wouldn't be a conversation. It would be a ritual, a slow exchange with silence between every sentence. Now soften the thought even more. A light month. A month is a gentle unit because it's not precise. It's not a stopwatch unit. It's a calendar unit. It's the time it takes for habits to shift, for seasons to tilt, for a person to say, wow, it's already been a month. In 1 month, light travels roughly 780 billion kilometers, nearly 1 trillion kilometers. And what does that feel like? It feels like this. If the sun were the center of a vast dark stage, and Earth were a small, bright idea close to the center, then a light month is the distance where the entire inner solar system begins to look like it's huddling near a single lamp. Even the outer planets start to feel less like separate worlds and more like faint dots in the same wide darkness. The space between becomes the star of the show. And this is where that phrase you included, photographs become postcards, really starts to land. A postcard isn't meant for urgency. A postcard is meant for presence. A postcard says, I was here. It's proof of distance. It's proof of time passing. It's the opposite of instant. When a spacecraft sends back images from far out in the solar system, the images don't arrive like a live stream. They arrive with the gentle delay of reality. And in that delay, something subtle happens. The universe teaches you to separate event from awareness. Something out there can happen now, and you can remain peacefully unaware for hours or for days. Space is full of things that have already happened, but haven't reached you yet. That might sound eerie at first, but it can also feel strangely calming, because it means the universe is not yelling at you. It's not demanding your immediate attention. It's doing what it does, on its own vast schedule, and you are receiving the story 1 page at a time. Now, there's one more gentle insight that light days and light months make obvious. When you travel outward, you're not just traveling through space. You're traveling into a different style of relationship with home. At Earth scale, you can call someone and they answer. At Moon scale, there's a slight delay, but it still feels immediate. At Mars scale, you have to plan your words. At outer solar system scale, you stop expecting a back and forth. You start sending messages like you're casting them into an ocean. And if you ever imagine what it would feel like to live far away from Earth, on a station or a ship or a settlement, this is where it becomes real. Not because of danger, because of delay. Because the most powerful part of distance is not the miles. It's the separation between your question and the universe's answer. And by the time you reach light months, the solar system has already taught you the lesson it was built to teach. Even in our own cosmic backyard, light is the only messenger that never gets tired. It crosses every gap at the same steady pace. And the farther you go, the more your whole definition of near begins to soften. A light day, a light week, a light month. Those words sound almost gentle, but they carry a truth that quietly changes everything. The universe is navigated not just with rockets, but with time. And once you accept that, you're ready for the next payoff. Because after days and weeks and months of light, the phrase light year finally becomes what it was always trying to be. A clean, calm way to describe distances so large that numbers alone can't carry them. There's a quiet moment that happens once you've lived inside light seconds, light minutes, light hours, and then the longer stretches, days, weeks, months. The numbers stop feeling like trivia. They start to feel like a new kind of geography. And that's when the phrase light year finally earns its place. Not as a dramatic label, not as a science fiction badge, as something practical, almost gentle, because a light year is not meant to impress you. A light year is meant to help you stay oriented when space becomes too large for the usual tools. Kilometers and miles are wonderful at human scale. They're perfect for roads, flight paths, coastlines, the long sweep of a continent. But once you're talking about the space between worlds, those units don't just grow. They lose their grip on meaning. You can say 150 million kilometers, and your mind treats it like a symbol on a page. You can say 780 billion kilometers, and it becomes a fog. Not because you're bad at math, because you're human. So astronomers do something simple. They pick a ruler that fits the subject. They choose the one thing that behaves the same way everywhere. Light. Light doesn't get tired. It doesn't need fuel. It doesn't slow down because the night is cold. It doesn't speed up because the day is bright. It just goes. Steady, reliable, unbothered. And if you're trying to describe a universe built out of steady motion and vast emptiness, it makes sense to measure distance in the language of that motion. A light year is the distance light travels in 1 year. That's it. Not mystical, not poetic, just honest. But once you've climbed the ladder, you can feel why that honesty matters. Because you already know what a year feels like. A year has seasons. A year has birthdays and holidays, school years and work years, beginnings and endings that aren't sharp, but still real. A year is long enough for a tree to change, for a town to shift, for a person to look back and say, that went fast, or that took forever. So, when the universe asks you to picture a distance too large for your street map brain, it gives you a year, a unit you can actually hold. Now, here's the payoff that sneaks up on you. Once you're measuring in light time, you can convert the solar system into something your intuition can carry without strain. You've already felt the basics. A light minute is about the distance light crosses in 60 seconds. 8 light minutes is the gap between Earth and the Sun, give or take. That's why sunlight feels immediate but isn't. It's always slightly delayed. The warmth on your skin is a message that began its journey when the world was just a little younger. A light hour gives you the outer planets in a way your mind can finally arrange. Suddenly, you can picture a signal leaving Earth, and you can imagine the wait. Not as a number, but as a stretch of time you've lived 1,000 times. And then the longer steps, light days, light weeks, light months, teach you the most important lesson of all. In deep space, far doesn't mean hard to picture. If far means slow to know. A light year takes that lesson and turns it into a stable, clean tool. Because as soon as you leave the solar system behind, the distances between stars don't want to be expressed in light months. You'd be stacking too many calendar pages. It would be like describing a cross-country road trip in inches. Technically possible, emotionally useless. So, the light year becomes the right unit at the right time. Not because it's dramatic, because it's efficient. It's the difference between saying, this star is about 40 trillion kilometers away, and saying, this star is about 4 light years away. One of those sentences feels like a billboard of digits. The other feels like a place on a map. And here's the strange comfort hidden inside it. A light year sounds enormous, and it is. But after you've climbed the ladder, you realize something almost funny. A light year is also just 1 year. Not a millennium, not an era, not forever. 1 year of light. A single steady run across the dark. And that becomes a rhythm you can return to, again and again, like a lullaby that keeps the scale from turning into panic. A light year is huge, and yet it's only 1 year of light. Say it again in your mind, slowly, not to force awe, to make the measurement settle, because the goal isn't to make you feel small in a harsh way. It's to make the universe feel legible. Now, think about why this matters for the sky above you. When you look up, you don't see a diagram of distances. You see points of light that all appear equally near, scattered across a dome. Your eyes don't come with depth labels. The light year gives you those labels without making your mind collapse under the weight of it. It lets you say, this star is a handful of light years away. This other one is hundreds. That faint galaxy is millions. It turns the sky into layered space, not flat decoration. It also gives you a quiet mental trick. Whenever you hear a distance in light years, you can translate it back down the ladder and feel what it means. 1/10 of a light year is a little more than a month of light. A light year is about 12 light months. 2 light years is 2 years of light. 2 full cycles of seasons carried across emptiness. 4 light years is 4 years. Long enough for a child to become a different kind of child. Long enough for the world to change its mood. Suddenly, the number becomes a story again. And this is what astronomers are really doing, even when they sound purely technical. They're trying to keep distances tied to something a human mind can track, because the universe is already hard enough to understand. The units shouldn't make it harder. Now let that idea land gently. A light year is not a flex, it's a kindness. It's a way of saying, don't fight the scale with tiny tools, use the right ruler. And once you accept that ruler, a few things become clearer without any effort. You stop thinking of the stars as far in the casual way. You start thinking of them as separated by time, by silence, by gaps that can't be crossed quickly, no matter how much desire you pour into them. And at the same time, the light year makes the distances feel clean, not chaotic, not ungraspable. Clean, because 1 light year is 1 year of light, a smooth unit, a steady stride. And from there, you can do what the mind loves to do when it feels safe. You can build a map. You can place the nearest stars into a neighborhood. You can imagine how far near really is. You can feel the strange fact that even the closest star system is not a nearby trip. It's a long separation measured in years of light. And that sets the stage for the next realization, one that changes the night sky into something deeper than scenery. If distance is measured in light years, then every star you see is also a timestamp, a message sent long ago finally arriving, a sky full of history delivered quietly, 1 photon at a time. Look up at the night sky for a few seconds and something subtle happens. Your eyes do what they were built to do. They collect faint light, they turn it into a picture, and your mind, without even asking permission, labels that picture as now, as if the stars are simply out there, shining in the present tense. But the moment you start thinking in light years, the sky stops being a backdrop. It becomes a time machine, not in the dramatic sense, not with glowing portals or spinning dials, but in the quiet, literal way physics delivers its surprises. Because light is not an instant thing. Light is a traveler. Every star you see is sending you a message, and you are receiving it late. Sometimes slightly late, sometimes unimaginably late. That sounds heavy, but it doesn't have to be. It can be strangely calming. It means the night sky is not one moment. It's a layered collection of moments stacked gently on top of each other. A soft archive, arriving 1 photon at a time. Start with the nearest star system. Proxima Centauri, the closest star to the Sun, sitting in the Alpha Centauri neighborhood, just a few degrees from the Southern Cross if you're in the right latitude. People hear closest, and the word makes a promise it can't keep. Closest sounds like a short drive. Closest sounds like nearby. But Proxima is about 4.24 light years away. 4.24, a number that looks small enough to ignore, until you remember what the unit means. It means the light leaving Proxima, right now, will not reach Earth until more than 4 years from now. And the light reaching your eyes tonight left that star more than 4 years ago. If you could somehow step outside yourself and watch this from far above, you'd see it as a simple fact, a beam of light crossing emptiness, steadily, without hurry. But from the inside your own life, it lands differently. 4 years is not nothing. 4 years is the length of a high school career, long enough for a child to become a different kind of child, long enough for new buildings to rise and old habits to fall away, long enough for a whole season of your life to quietly end. So, when you look at Proxima, you are not seeing Proxima as it is. You are seeing Proxima as it was, not ancient history, just slightly out of sync. And that's the gentle trick. Even the nearest star is not here. It's not now, it's a message in transit. Now, widen your gaze to the brighter stars people recognize by name. Sirius, for example. The brightest star in the night sky, low in the winter evenings for much of the United States, sparkling hard through the atmosphere like it can't decide on a color. Sirius feels close because it's bright. It feels familiar because it's easy to find. But Sirius is about 8.6 light years away. 8.5 years. If you stood outside on a cold night and watched Sirius twinkling, you'd be looking at light that began its journey when the world was in a slightly different chapter. Not a different century, just a different version of recent. And that changes what bright means. Brightness doesn't mean closeness. Brightness means you're receiving more photons per second. That's all. A star can be bright because it's nearby, or because it's enormous, or because it's burning with a kind of power that would make our sun feel modest. The sky doesn't arrange itself for our convenience. It's not a tidy diagram. It's a true map, full of misdirection, where distance and appearance don't always agree. Take Vega, a star that anchors constellations and old navigational stories and helped define zero on brightness scales in modern astronomy. Vega is about 25 light-years away. 25? That's not just a while. That's a whole generation. The light arriving tonight left Vega when the world was 25 years younger. Newspapers were different. Phones were different. The people standing under the sky were, in many cases, different people. And yet Vega's light has been crossing the same dark the entire time, indifferent to what humans do with their decades. There's something steady in that, something unbothered. Now, drift your attention toward the stars that feel less like pinpoints and more like characters. Betelgeuse, a red supergiant in Orion, one of the most famous shoulder stars in the sky, large enough that if you replaced our sun with it, the outer layers would reach out toward the inner solar system. Betelgeuse is the kind of star that makes people whisper about endings. It's near the end of its life, astronomically speaking, and it could go supernova someday, tomorrow, or in 10,000 years. Soon is a sloppy word when you're talking about stars. But here's the part that feels like science fiction, even though it isn't. Betelgeuse is hundreds of light years away. The exact estimate has moved over time as measurements improve, but it lives in that range, far enough that the light you see tonight left long before you were born, long before your habits and worries existed. So if Betelgeuse has already changed, if something dramatic has already happened there, we wouldn't know yet. We'd still be watching the older version, still receiving the earlier message. This is what people mean quietly when they say the sky is a time machine. Not because you can visit the past, but because you can see it, and not just see it as a story. See it as actual photons, carrying real information from a real event that happened when the universe was younger. That's an astonishing thing to be doing without trying. To stand in a driveway, or on an apartment balcony, or by a quiet window, and to let your eyes become receivers for ancient light. And once you accept that, the sky gains a new texture. It's no longer a flat field of dots. It becomes a layered depth of time. Some of the light is only seconds old, bouncing around your room, off walls, off pages, off your own hands. Some of it is minutes old, arriving from the sun. Some of it is a few years old, from the nearest stars. Some of it is decades old, centuries, millennia, and far beyond that. When you look at faint smudges of galaxies, millions of years, or billions. But even without galaxies, even with only the familiar bright points, you can already feel the strange truth. You never see the universe live. You see the universe by delay. Reality comes to you on a schedule, a steady stream of messages, always a little behind. And that delay is not a flaw. It's how the universe tells the truth. Because information needs a carrier, and light is the fastest carrier there is. Which means something else becomes clear, almost automatically. If the speed of light is the speed limit for information, then distance doesn't just stretch space. Distance stretches knowledge. It stretches response times. It turns conversations into waiting. It turns certainty into patience. And with that, a simple-looking unit like the light year quietly transforms into more than a measuring stick. It becomes a reminder of how the universe is built, not for instant updates, not for immediate feedback, but for long, steady travel through silence. A star shines, the light leaves, the darkness holds it, and years later, it arrives softly on the surface of your eyes. So, when you hear a star is 4 light years away, or 25 or hundreds, you can feel what that really implies. You are looking outward, and you are also looking backward. Not in a sad way, in a truthful way. In a way that makes the night sky feel deeper than it used to. A sky full of timestamps, a sky full of messages, a sky full of beautiful ghost images that may still be true or may already have changed, while the light, faithful and calm, continues on its way. And once you see the sky like that, one question starts to hover quietly at the edge of your thoughts. If light is the messenger, and it cannot move faster than it does, what does that limit really mean for travel, for cause and effect, and for the rules that hold the universe together? There's a quiet reason astronomers fell in love with light as a measuring stick. It isn't just that light is fast. It's that light behaves like a rule the universe refuses to bend. Not a preference, not a suggestion, a boundary. When people first hear the speed of light is the limit, it can sound like a technical detail, like a speed limit sign posted on an empty highway. But it's deeper than that. The speed of light is really the speed of cause and effect. The speed at which a change over there can become knowledge over here. It's the pace at which reality can update. And once you see that, light years stops being a cute astronomy word and becomes a kind of warning label. Distance is not just space, it's delay, it's waiting, it's separation baked into the structure of the universe. Here's a simple way to feel it. Imagine you're on a moving train and someone on board tosses a ball straight up and catches it. From their perspective, the ball goes up and down in a neat line. Now picture that same toss from the platform as the train passes by. From the platform, the ball doesn't go straight up and down. It draws a gentle arc forward because the ball is moving with the train while it rises and falls. Same motion, 2 points of view, 2 different shapes. Most of our brains can handle that, but light plays a stranger game. Replace the tossed ball with a flashlight beam. The person on the train clicks it on, and the beam shoots forward. From the train's perspective, it moves at the speed of light. From the platform's perspective, the train is already moving, so you might expect the light to move at the speed of light plus the train's speed. That's what everyday intuition whispers. And if the world worked that way, things would feel familiar. But the universe doesn't do that. On the platform, the light still moves at the speed of light. Not speed of light plus train, just the speed of light. So, where does the difference go? It doesn't disappear. It gets absorbed by time and space themselves. That's the core of relativity. If everyone measures light moving at the same speed, then different observers must disagree slightly about time and distance, in a way that keeps the rules consistent. Time becomes flexible, distance becomes flexible, but the speed of light stays stubbornly fixed. This sounds like philosophy until you notice something important. We don't accept this because it's elegant. We accept it because it's what nature does. If you move fast enough, fast compared to light, time dilation becomes real. Clocks run differently, not because they are broken, but because time itself is not absolute in the way we assumed. And the proof isn't only in deep space. It shows up in the sky above your head every moment. Cosmic rays strike Earth's upper atmosphere and create particles called muons. Muons are unstable. They should decay quickly, so quickly that, by everyday reasoning, most of them shouldn't survive long enough to reach the ground. And yet they do. They rain down through the atmosphere and show up in detectors at Earth's surface. The reason they survive is not because muons are lucky. It's because time runs differently for them when they're moving near the speed of light. From our perspective, their internal clock is slowed. They get more time, our time, to travel before decaying. From the muon's perspective, the distance through the atmosphere is shortened. Same outcome told 2 ways. Relativity doesn't merely explain it. Relativity is what makes it possible. The same story repeats in human-built machines. Particle accelerators, like the Large Hadron Collider, push particles to speeds so close to light that the old, comfortable Newtonian rules stop working. Engineers don't get to choose relativity or not. They have to use it because the particles behave relativistically, whether anyone likes it or not. Momentum, energy, time, everything obeys those equations. That's how we can predict what collisions will produce. That's how detectors are calibrated. That's how the whole architecture makes sense. And then there's an example you've probably used without realizing it: GPS. The satellites that make GPS work carry atomic clocks. Those clocks are extremely precise, but precision creates a new problem. Even tiny relativistic effects add up. Satellites are moving fast compared to us on the ground. And they're also higher in Earth's gravitational field, where time ticks slightly differently than it does down here. Special relativity nudges their clocks one way, General relativity nudges them another. If you don't correct for both, GPS errors grow quickly, drifting by kilometers. So, the reason your phone can tell you where you are, the reason maps feel steady and calm, is because the universe is not using one single time everywhere. Time has layers, and the speed of light is the thread stitching those layers into a consistent picture. That is why C is not just about light itself. It's about information. If something could travel faster than light, it wouldn't only be a faster spaceship. It would be a break in the logic of cause and effect. Because once information can outrun light, the order of events can flip depending on who is watching. Something could look like it arrives before it was sent. Not metaphorically. Mathematically, and the universe seems built to prevent that kind of paradox. It protects causality the way a shoreline protects the shape of an ocean. It doesn't stop the waves. It defines where the waves are allowed to be. So, when you measure distance in light years, you're doing something quietly profound. You're measuring how long reality takes to travel, how long it takes for a star's now to become your now, how far apart two places are, not just in space, but in the ability to influence each other. Because in a universe with a speed limit on information, distance isn't only about separation. Distance is about isolation. Not emotional isolation, physical isolation. A gentle, impartial rule. The farther you go, the more the universe forces patience on you. And once that sinks in, the night sky feels different again. Those stars aren't just far away. They're far away in the only way that truly matters. They are beyond instant reach, beyond instant reply, beyond instant certainty. They are a reminder that the cosmos is not designed for immediacy. It's designed for slow messages, for long travel, for light carrying truth across empty space, one steady step at a time. There's a certain moment, once the scale has really settled into your mind, when the imagination starts looking for an escape hatch. If light is the messenger, if cause and effect can't outrun it, if even a nearby star makes you wait years for a reply, then the mind does what it always does. It starts whispering, okay, but what if we cheat? Not in a dishonest way, in a deeply human way. We look at the rule, and we ask whether there's a loophole hidden in the geometry, whether the universe left a door unlocked somewhere, the way old houses sometimes do. That's where ideas like warp drives and wormholes live. They're not childish fantasies. They're serious proposals that physicists have written down with equations. They're the kind of ideas that earn quiet respect, even from skeptics, because they try to solve a real problem with real math. But they also carry a kind of weight, because the more carefully you hold them, the more they feel like beautiful glass objects, delicate, intricate, and easy to crack when you press on the details. Take the warp drive idea. The famous version is often linked to Miguel Alcubierre, who showed that, within general relativity, you can write a solution where space itself does something unusual. Instead of a ship moving through space faster than light, the space around it changes shape. In the story people like to tell, space contracts in front of the ship and expands behind it. The ship sits inside a kind of bubble, locally calm, not breaking any speed limit in its immediate neighborhood, while the bubble moves. It sounds like a clever workaround, like you found a way to travel without traveling. And there's something poetic about it too, because it reminds us that in relativity, space is not a rigid stage. It can stretch, it can curve, it can behave. But then you come to the first heavy problem. To make a warp bubble like that, the equations demand something we don't know how to produce in the required way: negative energy density. Exotic matter in the common shorthand. Not exotic like rare gemstones. Exotic like it behaves opposite to everything your intuition expects. In ordinary life, energy is something you add. You fuel a fire. You charge a battery. You warm a cup of coffee. Energy piles up as positive. Negative energy is stranger. It's like needing a region where the energy is below the normal vacuum baseline, below the quiet background level of space itself. Quantum physics does allow small hints of something like this in very controlled ways. There are subtle effects where you can create tiny regions that act as if they have less than nothing compared to the usual vacuum, briefly, locally, under strict conditions. But the key word is strict. In most serious discussions, negative energy is not a free resource. It doesn't behave like a tank you can fill up and haul around. It's more like a fleeting accounting trick the universe permits in tiny amounts, for tiny moments, with tight rules. And for a warp drive, you'd need a lot of it, arranged precisely, stable, shaped, sustained. That leads to the next heavy problem, stability. Even if you imagine for a moment that you can get the exotic energy and shape the bubble, you have to keep the whole structure from collapsing into something violent or meaningless. Because space-time isn't a sculpture you chisel once and walk away from. It's dynamic. It responds. It wobbles. It reacts to what you put into it. A warp bubble is not just a destination. It's a continuing act of balancing. And when the balance is delicate, small disturbances matter. A tiny asymmetry, a ripple, a perturbation could change the behavior drastically. Then comes an even deeper issue, one that isn't about engineering difficulty, but about logic, causality. If you can move effectively faster than light from one place to another, you're not only traveling faster, you're playing with the order of events. Because in relativity, simultaneous is not universal. Different observers slice time differently. If a signal can outrun light, then in some frames of reference, it can look like the signal arrives before it was sent. That's not just a storytelling twist. It's built into the structure of the space-time diagrams. And once you can do that, you can start building closed loops of cause and effect. Situations where an effect becomes its own cause. The universe begins to resemble a sentence that refers to itself in a way that cannot be consistently resolved. Some physicists take this as a sign that nature has a protection mechanism, an informal idea often called chronology protection, where the laws of physics prevent these time loop situations from becoming real, even if the math on paper allows them as abstract solutions. Whether that protection is absolute is still debated, but the discomfort is universal. Faster-than-light shortcuts push right up against the edge of what it means for the universe to be logically consistent. Now consider wormholes. Wormholes are the other great escape hatch. Instead of bending space into a bubble, you imagine connecting two distant regions with a tunnel. Not a tunnel in the ordinary sense, more like a shortcut through geometry. If space is a sheet, a wormhole is what you get when you fold the sheet and poke a hole through both layers. Suddenly, two far places become neighbors. And that idea is older than most people realize. It has a long history in relativity, appearing as bridges in the equations. But again, the details add gravity. The classic problem with wormholes is that they want to collapse. The throat pinches off. The bridge becomes unstable. To hold a wormhole open, you need, once again, exotic energy conditions. You need some form of negative energy or stress energy that behaves in a way ordinary matter does not. In simple terms, normal matter tends to make gravity pull inward. A stable wormhole throat seems to require something that pushes outward in just the right way, resisting collapse. And even if you could hold it open, you face the same causality tension. A traversable wormhole, under many scenarios, can be turned into a time machine. Not necessarily because you meant it to be, but because moving one mouth of the wormhole around, especially at high speeds or in strong gravitational fields, can create time offsets between the two ends. A shortcut through space quietly becomes a shortcut through time. And that brings the same paradox pressure right back into the room. So, where does that leave us? In a strangely comforting place, actually. Because these ideas aren't being dismissed as impossible in a lazy way. They're being examined at the deepest level of our best theories. They've been honored with attention. And the attention has revealed something sobering. The universe does not give up its rules easily. If there is a way to shortcut the light limit, it likely comes with costs and constraints so extreme that it stops looking like a practical road and starts looking like a philosophical boundary. A reminder that some distances are not merely long. They are enforced. And that enforcement is not cruel. It's just consistent. It means the cosmos is stitched together with patience. It means the night sky is not an interactive screen. It's a library, a record, a slow message. And in a way, that's the quiet beauty of it. Because when you stop searching for the loophole and you let the rule stand as it is, something shifts. Distance becomes honest, time becomes honest, and the universe becomes what it has been all along. A place where the fastest thing we know, light itself, still has to travel, still has to cross the dark, still has to arrive, one steady moment after another. There is a version of the future that feels almost like a bedtime story. Not because it's easy, but because it's strangely simple. A tiny craft, a distant star, a beam of light that becomes a sailwind. That idea has a real name, Breakthrough Starshot. It's one of the rare moments in modern space science where the dream isn't framed as magic. It's framed as engineering, brutal, precise, honest engineering. And that honesty is what makes it so compelling. Instead of building a massive ship with a crew, food, air, and years of life support, the plan is almost the opposite. Make the spacecraft unbelievably small. So small it becomes more like a message than a vehicle. A thin sail, something like a mirrored sheet, incredibly light. And attached to it, a star chip the size of a postage stamp, carrying sensors, a power system, a tiny radio, and just enough intelligence to survive a long, cold coast through the dark. Then on Earth, you build the hardest part, a vast array of lasers that can fire together like a single instrument. And you don't launch the craft in the old sense. You push it. You let photons do the work. Because photons carry momentum. Even though they have no rest mass, they can still exert pressure. It's gentle, so gentle that sunlight on a normal sail is more like a whisper than a shove. But if you concentrate light into an intense, sustained beam, that whisper becomes a relentless hand. If it works, the sail accelerates for minutes, maybe longer, long enough to reach a speed that makes the solar system feel small. A target often quoted is about 20% the speed of light. Not half, not 90%, not a fantasy speed, just 0.2 cents. And even that number is dizzying. At that speed, the nearest star system, Proxima Centauri, about 4.24 light years away, becomes a journey measured in decades, not millennia. Roughly 20 years to get there. Then comes the quiet punchline that keeps this story honest. Even after the craft arrives, the news doesn't arrive with it. If it sends a signal back at light speed, you wait another 4.24 years for that message to reach Earth. So the entire experience becomes a kind of time capsule. You build the mission, you launch it, you live your life. And if everything goes right, you might still be alive when the first faint data returns. An image, a measurement, a whisper of another sun. It's one of the most human aspects of Starshot. It's not a trip, it's a gift to the near future. And then the harsh beauty of it returns. Because nothing about this is easy. To accelerate a sail to 0.2 cc, you need an energy system that borders on the absurd. You need to aim an immense laser array with astonishing precision. You need to keep the beam locked onto a sail that's accelerating away from Earth faster than anything we've ever built. The sail itself can't be ordinary material. It needs to be extraordinarily reflective, so it doesn't absorb the beam and vaporize. It needs to be incredibly light, so the photon push actually matters. It needs to hold its shape, because if it wrinkles or tilts, the beam can push it off course. And off course is not a mild inconvenience out there. At interstellar distances, being off by a hair at the beginning becomes missing an entire star system later. So, aiming isn't just a technical detail, it becomes the whole discipline. You're trying to hit a moving pinhead with a beam from across a planet, while the atmosphere shifts, while the Earth rotates, while the sail accelerates into an environment that has no forgiveness. Then comes the problem that sounds small until you feel it in your bones. Dust. Space seems empty, but it isn't. Between stars, there are atoms, grains, tiny specks, truly small things. At ordinary speeds, they're nothing. At a fifth the speed of light, they become bullets. A grain of dust at 0.2 C carries so much kinetic energy that a collision could punch a hole straight through a tiny craft. Even a gas atom becomes a danger when you're moving that fast. So the spacecraft has to be designed like it's flying through a faint storm, one you can't see, one you can't avoid, one you can only endure. And endurance is the right word, because Starshot has another rule baked into it. There is no braking. No slowing down at the destination, no entering orbit, no graceful arrival. To carry enough fuel to brake would defeat the entire concept. Fuel has mass. Mass is the enemy. So, if Starshot succeeds, it succeeds as a flyby. A brief streak through the Proxima system, a fast glance, a rush of sensor readings as planets swing into view and vanish again. It's not a visit. It's a drive-by at cosmic speed. That sounds disappointing at first, until you remember what it really is. It's the first time humanity would ever touch another star system with something we built. Even a single blurry image of an exoplanet's crescent, even a spectrum hinting at an atmosphere, even a measurement of magnetic fields or stellar wind, those would be historic. And then there's the last quiet challenge. How does a postage stamp craft call home from light years away? You can't mount a big radio dish on it. You can't carry a nuclear generator without adding mass. You're dealing with minuscule power, a tiny antenna, and a signal that spreads outward, thinning into the background noise of the universe. So communication becomes its own kind of miracle. Maybe it uses the sail as an antenna. Maybe it stores energy and transmits in rare bursts. Maybe Earth has to listen with instruments more sensitive than anything we use today. And still, the message would arrive faint and fragile, like trying to hear a single voice across an ocean while the wind moves and the waves never stop. That's the price of a real dream. Not fantasy, not faster-than-light shortcuts, not wormholes, just physics, just light. A beam pushing a sail, a tiny craft carrying a human question, a destination that will not wait for us, and a return signal that will not hurry. And if you let that settle for a moment, it becomes strangely calming. Because it shows you something important about the universe. The rules are strict, but they're not mocking us. They don't forbid wonder. They simply ask for patience, precision, and the courage to build something that might outlive the person who started it. A slow message sent toward another sun, and a hope, quiet, steady, and very human, that one day far ahead, we'll finally hear it come back. A conversation across a room feels instant. You speak, and the reply comes back before your brain can even label the pause. The space between two people becomes invisible because sound crosses it so easily. That's the version of communication our nervous system was built for. Even when technology stretches it, when a voice crosses a continent or an ocean or reaches you through a phone, your body still expects the rhythm of normal life. Question, answer, laughter, another sentence. But once you push beyond the solar system, distance stops being a background detail. It becomes the main character. At 4.24 light-years, Proxima Centauri is close in the way a mountaintop is close when you're looking at it from a window. It's there, it's real, it's in the same sky. And yet, if you sent a message there tonight, the earliest possible hello would arrive more than 4 years from now. Not because the transmitter is weak, not because the receiver is broken, because reality has a speed limit. So, what happens to society when the delay isn't minutes but years? Something simple changes first. A conversation stops being a conversation. It becomes a sequence of letters. You send a question. You wait. You live an entire life season. Holidays, news cycles, birthdays, losses, small victories. Then, years later, an answer arrives that was written by someone who lived in a version of the world that no longer exists. Even on Earth, we felt small hints of this. Old postcards arriving after a long trip, voicemails saved for later, time zones turning good morning into good night. But this would be something deeper. With a 4-year one-way delay, even the fastest exchange becomes an 8.5-year loop. A child could be in elementary school when the question is sent, and preparing for high school when the reply returns. If you've ever had a friendship drift simply because you didn't talk for a month, imagine what silence does over a decade, especially when it isn't emotional silence, but physical law. In a world like that, you wouldn't argue in real time. You wouldn't negotiate in real time. You wouldn't manage anything in real time. You would make decisions locally because the sky doesn't permit anything else. And that leads to the next quiet shift. Governance changes shape. If a colony existed around another star, Earth couldn't run it in any practical sense. Earth could send guidelines, encouragement, warnings, history, art, messages that feel like a lighthouse beam. But the people living there would not be living inside Earth's tempo. They would be living inside their own. By the time a crisis report reached Earth, the crisis would already be a chapter in a history book. By the time Earth replied with advice, the advice would be for a world that had already moved on. So, authority becomes less like a command and more like ancestry. Earth becomes a parent planet in the emotional sense, but not the logistical sense. And then culture begins to do what culture always does when groups are separated. It drifts. Language shifts, slang grows, meanings bend, traditions evolve, even values slowly take on a different flavor, not because anyone intended it, but because local life shapes local minds. It's not frightening, it's natural. Distance doesn't just delay messages, it creates different versions of now. If you stretch this further, the effect becomes almost poetic. At 10 light years, the fastest back and forth becomes more than 20 years. At 100 light years, it becomes more than 2 centuries. A message becomes something you send to a future you will never meet. And in that reality, communication stops being about coordination. It becomes about connection. You don't send messages because you expect an answer soon. You send them because it matters to leave something behind. A proof that you were here. A record of your thoughts. A small, careful piece of your world. And the strangest part is that we already do this. Books are delayed communication. Music is delayed communication. Paintings, photos, journals, recordings. They are messages to strangers in the future. Interstellar distances simply make that truth unavoidable. So, when people picture first contact, 2 species chatting like neighbors, there is a gentler, more realistic possibility. First contact might look like archaeology. A signal received long after it was sent. A pattern recognized by minds that didn't exist when it began. A greeting that arrives from a civilization that may already be silent. Not because tragedy happened, but because time is simply large and overlap is rare. And if you let that settle, it can feel strangely calming, because it reminds you that meaning doesn't require immediacy. Some of the most important messages in your life were not instant. They took time to arrive. They took time to understand. And out there, between the stars, time is built into every sentence. A letter written in light, a reply that is always traveling, and a quiet lesson hidden inside the delay. In a universe this wide, patience isn't just a virtue. It's the only way anything can ever speak. Step back from the nearest star for a moment and let the scale change under your feet. Proxima Centauri is close enough to feel like a reachable dream. But on the map that astronomers carry in their heads, Proxima is still just the next mailbox on the street. Because the Milky Way is not a little neighborhood. It's a city of stars about 100,000 light years across. That number is so large it stops being a number and becomes a landscape, a width, a whole horizon. If a beam of light started on one rim of the galaxy and traveled perfectly straight, it would still be traveling long after every human story you've ever heard had faded into deep history. And in that setting, our own presence becomes something surprisingly small. For about a century, we've been leaking radio into space. Broadcasts, radar pings, accidental noise, fragments of ourselves riding outward at the speed of light. That expanding sphere is sometimes called our radio bubble. And after roughly 100 years, that bubble is only about 100 light years in radius, which sounds impressive, until you remember the galaxy is 100,000 light years wide. Our loudest hello doesn't even fill a tiny corner of one spiral arm. It's a thin mist around one ordinary star, in one ordinary neighborhood, on the outskirts of a much bigger home. And that's where the Fermi whisper begins, not as a panic, but as a quiet question. If the galaxy is this vast, why does it feel so silent? Maybe civilizations are rare, or maybe they're common, but separated by distances so extreme that their eras don't overlap. Signals could pass through regions like ships in the night, both real, both bright, just never in the same place at the same time. Or maybe the loud phase doesn't last. A species might become quieter as it gets more advanced, using tighter beams, fiber-like networks, or physics we don't recognize as radio at all. The ocean could be full of life and still look calm from the shore. So, when you stare into the Milky Way, you're not just staring into distance. You're staring into a timing problem, a scale problem, a patience problem, and in a strange way that can soften the edges of everything. Because it means the silence isn't personal, it isn't targeted. It may simply be the natural outcome of a universe where space is immense, and light, faithful as it is, can only carry so much, so fast. There's one last twist to this ruler we've been using tonight. Because even light, steady, honest, and unimaginably fast doesn't get the final word everywhere. Out on the largest scales, the universe is expanding, not like an explosion from a single point, but like space itself is stretching, quietly, constantly. A simple way to feel it is to imagine a moving walkway in an airport. You can walk forward at a steady pace, and still find that the walkway is carrying the floor away beneath you. Not because you're moving backward, but because the ground is changing. In the same gentle way, there are places in the universe that are simply being carried away by the stretching of space. And beyond a certain distance, light that leaves them today will never reach us, because the space between us grows too quickly, forever adding new darkness in between. That boundary is called a cosmic horizon. It's not a wall you could touch. It's not a line painted in the sky. It's just a quiet limit on what can ever become connected to you, no matter how long you wait. And strangely, that can be comforting, because it means the universe has a natural softness built into it, a kind of privacy, a gentle reminder that you don't have to hold everything, you don't have to know everything. Some distances are simply part of the design, and here, back on Earth, that perspective can do something kind. Not by dismissing your worries, not by telling you they don't matter, but by placing them in a wider frame, where they can breathe. You are a small, warm mind inside a very old universe, made of stardust, quietly watching Starlight arrive, photons traveling for minutes, years, centuries, just to reach your eyes. If this episode helped you relax or gave you that calm, wow feeling in the background of your night, I'd love it if you liked the video and subscribe to the Quantum Slumber. It helps this channel reach more people who need something gentle to fall asleep to. And if you feel like it, leave a comment. What part of the universe feels the most mind-blowing to you? The moon, the nearest stars, the Milky Way, or the horizon itself? For now, you don't have to do anything else. Just let the room stay quiet. Let your breathing stay slow. And as the last few thoughts drift away, may your mind grow lighter, your body softer, and your sleep come easily. Good night.